Hello, everyone, and welcome to my class. Today we'll be talking about more algebra, and we're going to be doing some algebra problems. I've just shared my screen, so can everybody see my screen when I open the chat and go to the participants? Can everybody see my screen right now? You see the PDF and what we're learning today? Say yes in the chat if you can see my screen. Yes, very good. Okay. And I expect everyone to be able to do these problems, or if I you can chat to everyone. When did that get changed? Well, I have no idea how to fix the settings. So okay. But please minimize the chatting in the chat box to everyone, so you can actually focus on the class. And I expect you to be able to actually answer the problems when I do have problems for you. And when I ask you if you understand, you should say yes or no if you don't understand. But at least have a response and let me know that you are alive. Because if you're not, that would be a very big problem that we would like to avoid. No dead bodies in here. That'd be a very good thing. All right. Let's start. So, algebra problems number 5. If you have not been to the first 4 classes, don't be worried, because this is just, we're starting on another subject today, mainly number theory. So, and we may touch up on some other subjects later. Okay, so number theorems and principal square root, that's what we're doing first today. And then I'm going to do some more on absolute value, exponents and radicals, and then radical laws. All right, so let's start with our first number theorem. Hold on, what's this? Okay. Our first number theorem is, this applies to linear equations, algebraic equations. Okay, you probably already know this, all right? But we're going to be learning how to prove this. And the thing with proofs is that you can't use like examples with real numbers. You have to use some actual theorem. Okay, so let me write down the theorem. So the theorem is, if A is less than B, then A plus C is less than B plus C. Okay, and C is a real number. And this is quite an important theorem to remember when you are doing algebra. Okay, when you're solving linear equations. I know this is very obvious, not very hard. But does anybody know how to prove this? Right, the proof part is very important. Okay, proof. How are we going to prove this? Does anybody have any ideas? And you can do, if you have any ideas, you can put them in chat box. Any ideas about how to prove this? Okay. No ideas? Steven, any ideas? Edward? Do the new students have any ideas? Austin? Andrew? No? Okay, so when we are proving, let's say, let me show you a wrong proof. Okay, how do we prove this if it's wrong? Okay, if it's wrong, how do we prove this? Okay. So this is an example of wrong proof. Okay, A, what is A? A is 3. What is B? B is 4. Okay, and our C is going to be 1. 3 plus 1 is less than 4 plus 1. All right, we cannot do this. And why? Okay, I'm going to talk about that later in more detail, but we cannot prove theorems with real numbers. That is not possible because we have so many examples to actually prove that this theorem is true. So it's impossible to prove using examples. So what are we going to do is let's rephrase this. A is less than B. What is that? All right. If A is less than B, who knows what else is true? If A is less than B, what does okay. If you subtract C from both sides, you get A minus C is less than B minus C. All right, so this very very good guess, but you cannot do that either. Because if you prove using that way, you're already assuming that the theorem is true, and we don't want to assume that the theorem is true. So if you have A is less than B, who knows what else does that imply? Okay, so if A is less than B, then that means that B minus A is greater than 0. Okay, so what does this equal? You have B is greater than A, or A is less than B, right? And that, if you subtract A from both sides, then B minus A is positive, right? So that also implies that B plus C, okay, minus A plus C is greater than 0, okay? And then, since the C cancels out, then we get B minus A is greater than 0, and we're back to A is less than B. So that is how you prove this theorem. This is very important when you're proving theorems, and once you're getting familiar with proving theorems, you know how it works. So does everybody understand how I am proving this theorem? Because we reverted or rephrased this A is less than B, okay, and then we get that B minus A is positive. Does everybody understand that? Say yes in the chat if you understand, or no if you don't understand. And this is quite an important theorem, so I would advise you to take notes on this as well. So yeah, yes, very good, very good. Okay, so does anybody want to take notes on this, or are they good? Or have they already taken notes on this? So any note takers here? No? Okay, so the second theorem is very similar to the first one. The second theorem is AC is less than BC, okay? If C is greater than 0. Okay, so how are we going to prove this? All right, how are we going to prove this? Again, we have one identity is less than another identity. So let me remind you what we did back here. Basically, we moved one identity to the other side to make B minus A is greater than 0. So using that same method, what new inequality would we get here? Okay, we got B minus A is positive last time. How can we basically rephrase this to prove it? Any ideas? Any ideas? How are we going to prove this? Okay, so what does AC is less than BC imply? Yes, BC minus AC is positive. That is what it also means. So BC minus AC is positive, and let's factor this. All right, let's factor this. So the next step in our proving this, how are we going to do this? So since there's C on both sides, then B minus A times C. Okay, and we're using basically reversing the distributive property to factor this. Alright, so basically this is greater than 0. Right? And how do we know that? Because we already know that C is greater than 0, and also that B minus A is greater than 0. Okay? So with that, then the whole thing is greater than 0. Okay, and that we go back to AC is less than BC, or BC minus AC is positive. So that is how we prove our second theorem. Are there any questions? Any questions? Yes. Well, Stephen, we already know that C is positive, so there's no use trying to figure that out. Pretty sad thing to do. Okay, so what is this? Why does this keep popping up? So, does everybody understand these theorems? Say yes in the chat if you understand. If you don't respond, I'll assume you're deaf, or you have problems with a computer, or you're dead. 3 possibilities. Ah, so only 2 people are alive here. That's sad. Okay. So all of you are either deaf, have problems with your computers, or dead. Well, that makes it 3 people that are alive. Well, including me, there are 4 people that are alive in this classroom, and 7 people that are not. 7 casualties, 911. Yes, call the funeral service. Okay, so proofs. How are we going to go about proving these? Okay, so this is in general for all theorems. In general for all theorems. Okay, so number 1, we cannot prove by examples. Okay, you cannot prove by examples because a theorem is supposed to go for is supposed to be true for all examples. So we cannot prove by examples because there are in infinite examples. So we cannot prove them all. For example, A is less than B, then A plus C is less than B plus C. Okay, and C is real. So we can, okay, this is a wrong proof. This is our proof, all right? 2 is less than 3, so 2 plus 1 is less than 3 plus 1, okay? But there are infinite examples. What if A is 3 and B is 4, okay? It's going to go on and on. So we cannot prove by that way. Cannot do that. Number 2 is that how do we disprove a statement? We're learning about how to prove a statement, but how do we disprove a statement? Now, disproving a statement is actually super easy. It's easier than actually proving the statement. So how do we disprove a statement? Okay. How to disprove a statement? Does anybody have any ideas on how we're supposed to disprove a statement? Assume it's true. All right. Okay. Then prove it's what? Then prove it's contradict. Okay. Edward, that's the wrong word. Then prove, yes. Contradiction, not controversial. Okay, so usually when you disprove a statement, well, I was going to say, use an example that doesn't fit. All right, use an example that doesn't fit. For example, let's say we have this theorem a divided by, why is there a divided sign on it? A divided by b divided by c is equal to a divided by the quantity of b divided by c. Okay, how are we going to do that? This is not true, obviously, but all we need to do to disprove a statement, because theorems are for all examples, all we need is one insufficient example, such as 1 divided by 2 divided by 3 does not equal 1 divided by the quantity of 2 divided by 3. Okay, we only need one example. Okay, one example is sufficient. Only one example is sufficient. Okay, and does everybody understand where I'm going with this? Proof by example, yeah. And Stephen and Edward said something about what? Proof by contradiction. All right, that is another type of disproving something. All right. So actually, proof by contradiction is pretty basically that kind of relates to what we're doing here, right? We're assuming that this is true and we're plugging in numbers, right? And then once we're done plugging in, we actually calculated, and what is this equal to? 1/6 supposedly equals 1 divided by 3 halves. All right, that of course is not true. Okay, and once we assume it's true and then we actually calculate it out, we're contradicting it. We're actually contradicting it. Okay, so that is basically proof by contradiction. So actually, this is pretty interesting proof by contradiction. We have actually. Do you want to see an example on how we prove by contradicting? Okay, this is sad. Who the heck is Jim? Is he related to Jeff or John or Jigglypuff? I don't know. Okay, so proof by contradiction. Let me show an example. So, let's say, actually, I'll talk about that when we get to radicals. let's do that. So absolute value, what do you all know about absolute value? Okay, absolute value, what is that? Okay, who knows what absolute value is? So no one knows about absolute value. Well, that's sad. Okay, come on. It's not that hard. Okay. Any ideas on absolute value? 2 lines. Vertically. Yeah. Okay. Great. Yes. Yep. Yep. Just 2 lines vertically. Yep. Nice. Yay. Yay. Okay. The absolute value, Stephen is right. The distance from 0 on the number line. Okay. The distance from 0 on the number line. However, that is not actually the definition of absolute value, because that's just on a geometrical basis. All right. What is this? Okay. You have 0. Okay. And then this is basically the absolute value of x, and x is right here. Okay, that's on that's a visual idea of absolute value. So what exactly is absolute value? So let's define that, and make sure to take notes. This isn't what you normally expect, but once I explain it, it'll probably make sense. So the absolute value of x equals x if x is greater than or equal to 0. However, the absolute value of x equals negative x if x is less than 0. Okay, so basically this is when you unravel the absolute value, because when you have absolute value, it's not entirely simplified. We usually want to simplify that. So absolute value turns into just x if x is greater than or equal to 0. The absolute value turns in, okay, x just becomes negative x if x is less than 0. And this might not make sense, but let's make an example about this, right? So examples. Right, how are we going to do this? Actually, let's do one on here because we still have space here. So -5. You want to find x, right? What is x? Okay. And since this absolute value, right? This absolute value, we're going to simplify. We're going to simplify it. Now you all know that the absolute value of -5 is 5, right? But let's use this formula right here. Okay, so what is x? The x is the number inside of this absolute value. And this says that if x is less than 0, then the result will be negative x. So -5 indeed is less than 0. So the result, the value of the absolute value of -5 will be negative x, which is negative 5, and that equals 5. And this is an example of this. Okay. And then let's do another example. What does this equal? The absolute value of just +5. And this states that it will just equal x if x is greater than or equal to 0. So this just equals 5 as well. So that is the definition of absolute value. Are there any questions? Any questions on this? No questions. Any questions? So no one here is alive. Who's alive here? If you're alive, please put yes or no in the chat. Come on, it isn't that hard. Do you understand or not? It's not that. Oh, finally, 2 people other than me are alive. Oh, 3, 4, 5. Oh, I see how it is. So 5 people are still dead. That's very sad. But at least we have 6 people alive now. What? No, 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 no. Huh. So many no's. Okay. This is so sad. Okay, so let's do some examples then. Hopefully you'll understand by then. So let's do this. Okay. So what is the absolute value of pi? What? Hold on, let me write it lower. This pen always does stupid stuff when it's high. Okay. Pi minus 4 absolute value. What is the absolute value of pi minus 4? Now, if this theorem says that if the absolute value of x, okay, if so let's pay attention to this. If x inside the absolute value is less than 0, then the result of the absolute value will be negative x. So let's see if pi minus 4 is negative. What is pi? 3.14, right? 3.14 minus 4, that's going to be negative. Negative 0 point something, right? Negative 0.86 or something like that. Okay. So it's negative, right? And when x and pi minus 4 right here is x. Okay. And x right here, what is this? Why won't this go? Okay. If x is less than 0, then the result of the absolute value will be negative x. So basically the answer is negative pi minus 4, which is 4 minus pi. All right? Does everybody understand how we get that? Okay. Yes. So now let's basically hold on. Do you still understand or not? Do you still have problems with this or something? Edward, you got the correct answer, so I'm assuming you understand. Steven, everybody else, do you understand? And of course they're leaving because they don't understand. Oh, that's sad. Yes. Okay, good, good. Okay, so Let's do another example. Number 2, x plus 3. And what's the absolute value of x plus 3 if x is less than or equal to -3? Okay, what is that? Okay, I'm expecting you to answer this. Any answers? All right, at the same instant. Of course, it's Edward and Stephen fighting for the crown again. Excuse me. Edward is correct. -x minus 3. Very good. Now, if x is less than or equal to -3, okay, it could equal to -3, which means that it would be the absolute value of 0. But it could also equal to -4, and then it's negative. So we're going to assume it's negative. Okay, negative. And what we do when we're negative, we just take the whole -x. Right? This is going to be that's going to be -x minus 3. Okay, and we also have 0. It could also be 0, but in this case we're going to ignore that 0. And Stephen is kind of correct. Maybe. Hold on a second. If x is less than, oh, I see. Ah. So Stephen is also correct in a sense, because basically what he's doing is he's taking the absolute value of x, and x is less than -3, so it's going to be positive. And then that we're going to subtract 3. So let's say x is -4. Okay, so the absolute value of -4 minus 3 equals 1. Now let's -x minus 3. -4 minus 3 also equals 1. So both answers are correct, but I prefer you do this way because we are ignoring the 0 here. So, yeah. Okay. So, are there any questions? Any questions? If not, we are going to move on to exponents and radicals. No. Okay, good. No questions. So, exponents and radicals. How are we going to do this? Let's start with some problems, actually. Yeah, let's just move on to problems because I'm sure all of you know what you're doing here. Okay, so radical theorems. Let's actually talk about that first. So principal square roots. Okay. Let's talk about principal square roots. Does anybody know what square root of 4 is? What is the square root of 4? What is the square root of 4? What is the square root of 4? 2. Yes, very good. Now, what about -2? Where'd that -2 go? -2 squared is also equal to 4, right? Is -2 an answer as well? Do you think -2 also fits this? 4 square root? Okay. X equals plus minus 2. All right. But we're not doing that, right? This is with just numbers. There is no X. So, therefore, it just equals 2. Okay, so what is principal square root? Principal square root is it's the definition is that of principal square root. Okay, if a is greater than 0, then a to the nth root is positive. It is any positive number. B such that b to the n equals a. However, it cannot be negative. So that is the definition of principal square root. And then number 2, if a is less than 0 and is odd, then a to the nth root equals b, which is less than 0, such that b to the n equals a. Number 3, if a is less than 0 and is even, then a to the nth root is undefined. Or in terms of I. Right, so it is undefined if a is less than 0 and n is even, right? I mean, -1 to the third power, that just equals -1. However, -1 to the fourth power, that is not possible. So, does everybody get principal square root? And also, let's do another one. What is y? Okay, so the square root of x squared. What is that? What is the square root of x squared? Any ideas? What's the x square root of x squared? What's that equal? Huh? X? Just x? X is incorrect. Austin, X is incorrect. Stephen, oh, the absolute value of x. That is correct. The absolute value of x. Because it has to be a positive number. Let's say x is -4. Then it has to be the absolute value of -4 to be principal square root. So please remember this when you're solving. Okay. So now for some examples. Let's do some examples. All right. So example 1. Please do this in your scrap piece of paper and all right, how are we going to do this, guys? How are we going to do this? Okay, I'll give you a couple moments in chat. A couple moments to put your answer in chat. And then I'll go over this problem and There may be some things that are pretty tricky with this problem, but it shouldn't be too hard. All right, shouldn't be too hard. Oh, is that? Wow. Very nice, very nice. That is great. Stephen, you're incorrect. Edward, you're correct. Wow. So good. Very nice. Okay. Well, Stephen, you're still correct, but don't put the absolute value on the whole thing. Simplify it to just y minus 1. Very good job, Edward. Good job to you both. Very nice, very nice. Okay, so great job. How are we going to solve this? Basically, what is this? So let's separate it. Okay, x to the second. Okay, this is what this is. Okay, times y minus 1. Okay, to the third, to the fourth. Okay, so you see, these cancel out. These just cancel out. And then we're stuck with just y minus 1 to the third and x to the second. Now, x to the second, that's just x to the second. We're not subtracting or adding anything, so no absolute value on that. We don't need to do that. But y minus 1, what if y is negative 1? And if we have negative a negative number here with n as even, with 4 as an even number, then that'll be undefined, right? So we must have an absolute value on y minus 2. So y minus 1 actually, y minus 2. So this is our answer. X squared times the absolute value of y minus 1 to the third. Very nice. Yay. Okay. Great job. Great job. So let's do some more examples before we're working on rationalizing the denominator. Okay, so how are we going to do this? Let's do this. Okay. Okay. So write this problem down with me, and then you're going to solve it. Hopefully. All right. So how do we solve this? I'll give you a few moments and write out your answer in chat. And I'll give you a hint. Please combine these first, and then proceed to do the problem. Any answers? Who is that from? I bet it's from Stephen. Oh no, it's from Edward. Wow. Better get your game up, Stephen. What the heck is that? Oh well. Can't expect much. So how are we going to solve this? Let's combine them. Combine the exponents, add them up. So these exponents have to be multiples of 5 in order to simplify, right? So what are we doing here? Let's do this. What is this actually? This is 5, the 5th root of x to the 10th times the 5th root of just x times the 5th root of y to the 5th, right? And let's simplify these two. We can simplify these two. And once we're done simplifying, we get x squared times y times the 5th root of x. So that is our answer. Okay, does everybody understand how we get this? Oh, you forgot how to type it. Just do, I mean, if you're really desperate, you can just do square root of, I mean, if you're actually writing it on a computer, it's actually pretty complicated if you're going to do it on computer. So square root of 5 times, raised to the power of 1/5. Wow, that is complicated. All right, then you don't have to do it if you don't want to, but okay. So, oh, and also you can't do that right next. Wow, so that is how you write it on computer. That's very sad. Okay. Okay, so now let's do rationalizing the denominator. So why do we rationalize the denominator? The denominator? What are we doing? 1 over the square root of 5. What is that? That's not simplified enough, right? That's what the teachers tell you. So what we're supposed to do is we're going to multiply by square root of 5 over square root of 5. Basically just multiplying by 1. So it doesn't make a difference, but what we get is square root of 5 over 5. And now we have a rational number on the bottom, so there we go. Why do we need to do this? Why? Okay, why? What we need to do is, let's say we have square root of 2 over the square root of, okay, actually that's not it. 1 over the square root of 2, okay? Why do we need to rationalize the denominator? Can anybody tell me what is the square root of 2? What is the square root of 2? Okay, the square root of 2 is a very long decimal. I mean, 1.1, 1.41423 and 1. Okay, this is just from the calculator. The calculator can't even write all the decimal points because this is a never-ending irrational number. So we can't actually find we can't really find a nice answer for this. We need to round it. Okay. So if we rationalize the denominator, it's going to be square root 2 over 2. That's basically 1.1, 1.414 ... question mark over 2. Now that's easy, right? Okay, hold on. You divide that by 2, it's just going to be what? 0.0 707 dot 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 question mark. Right? That's how we're supposed to just, if we're dividing this decimal, then we can actually divide it, right? But we're dividing by this decimal, okay, with a real number and with a rational number and a irrational number, then we're gonna get another irrational number. But with this, we can actually kind of get an idea of what it is. So for better division, we rationalize the denominator. Okay, so wait. So now let's do some examples on rationalizing the denominator. Actually, oh wait, we don't have much time. Okay. Actually, since this problem is kind of hard, so kind of long, actually, not that hard, but kind of very, very long. So I'm just gonna end this class here, and I'm gonna talk about this question next class about rationalizing the denominator. Okay, so I'm gonna end the class here. Thank you for listening, everyone. Okay. Bye.